Okay, so with all of that in mind, so this talk will end up being between 1 and 3 parts long, depending on how far I can get and how quickly I can communicate information to you and how much time I have. But the overarching goal of my research is to elucidate and characterize our default assumptions about the world, the visual world, especially in the context of social cognition. So I, in a way, look at the visual roots of social cognition by, applying like a vision science perspective, because that's my original training, a vision science perspective to questions that are usually thought of as in the domain of social psychology. So because of this mixing of methods and questions and theoretical lenses that I'm going to use throughout this talk, I hope that this kind of work can bridge the gap between, not only cognitive and social psychology, but to have a broad impact on other disciplines as well. One of the things I'd like to start with, I always start with like a little demo or exercise of imagination, but imagine that you've just moved to a new state or country, you're at the DMV, you're trying to get your driver's license switched over, but the forms are very confusing and you're not sure what to do. These are the only 2 clerks available. So the question is, which of these 2 people would you rather ask for help? And if you're anything like the participants in our studies, you'll find yourself gravitating towards the person or the face on the right, because it just gives some sense that maybe you could put into words, maybe you can't put into words, that they're more warm or friendly. And these are the kinds of decisions that we make all the time in our daily lives. Decisions about who to befriend, who to approach, who to buy from. And these kinds of decisions are, in a way, automatically and irresistibly informed by what people look like, the face that they present to the outer world, the impressions we have of their faces in any case. Because when you look at a face, you can't help but read it in some sense. There are features that you read out of faces very unproblematically, like say age. We're pretty good at telling how old someone is from their face. We can tell the difference between a kid and an adult usually. But then there are features that you read into faces, usually problematically, like how trustworthy you think that person actually is on the basis of, say, a single photograph. These kinds of impressions happen super duper fast. We know from past work that they happen in less than half the time it takes to blink your eye often for basically anything we've ever measured. So in terms of impressions of trustworthiness or dominance or competence, by like about 50 milliseconds, for most traits, you've reached like self-agreement. This is not to say that you become accurate at 50 milliseconds. It's just that you don't change your mind after a 50 millisecond exposure to that image. We extract demographic features just as quickly, like perceived age or perceived gender. And one of the cool things about these kinds of impressions is that they're shared. People agree on these sorts of things. And because they're shared, that allows us to model them. So this, for example, is an older model from our lab of perceived trustworthiness, where I'm going to make the face look more and more, quote unquote, trustworthy. A lot of things change about the face, including it becomes more smiley and feminine. And then we're going to make it look less and less, quote unquote, trustworthy, where it becomes more and more masculine and scowly as we go through the continuum. And these kinds of impressions matter a great deal, but they can be misleading. So, for example, you can predict election outcomes. This was from Alex's work in science, like years and years ago now. You can predict election outcomes about 70% of the time, just on the basis of the portrait photographs of the 2 candidates. And even kids can do this. This thing is just being a little bit finicky, so I'm just going to use the buttons. Even kids can do this. So you can have, I believe it's Swiss children predicting French election outcomes 71% of the time, just based on the photographs. Forget about policy, forget about history, forget about what gaffes they make in the newspapers. It's just the pictures. So it just shows that our impressions have this real causal impact on the world at large, even if they happen to be inaccurate, even if they're misleading. And this demands an explanation. It demands scientific inquiry. So for example, more dominant looking cadets in the military reach higher military ranks. More competent looking CEOs end up getting paid more, even if they aren't actually more competent as measured by various metrics thereof. And more trustworthy looking borrowers in context of loans are more likely to get loans, they get lower interest rates, etc. Right? Closer to home, quote unquote, in the lab, we know from like simple economic games, like trust games, that the more trustworthy you look, the more likely you are to earn more money in these sorts of little games. But because these impressions are so widespread and they're so consensual and they're so impactful, there's an open question as to how accurate these things tend to be. And the evidence for that tends to be very mixed or very weak. It's weak in my opinion, it's mixed at best. But one of the, I won't go into the details of this particular experiment, but basically they looked at faces of real people who played trust games, and they tried to understand who was going to reciprocate and who was going to defect. And they found that say 52% of the time, you could detect who is going to defect if you crop the face and make it grayscale, and there are all these caveats. But it's just the case that defectors are a much smaller percentage of the population. So people are just really inaccurate at this task. And if you literally just close your eyes and don't use faces at all and just cooperate with everybody, you would end up doubling the amount of money you make in the same kind of game that is used to show that these effects are real. So as a result, it's this weird, messy literature. The evidence is weak. And to my mind, I'm like, there's got to be a way that these kinds of stereotypes can propagate despite weak evidence. So that's what I wanted to ask in this kind of question. How is it that our stereotypes propagate despite weak evidence? Or in a world where maybe one day in the past they were true, but now they're just not? How do they keep going? What keeps them going? Question?
They're very kind, like grandpa. It's more like kind. I feel it's like
Yes, so it's true that if you look at older people's faces, there are some findings where you can accurately tell some stuff right about their internal experience accumulated over the course of their lifespan. You can also do pretty well at detecting health, right? Perceiving health in these older kinds of faces. So there was this great study with, I believe, Dutch twins, where they have these really quite old septuagenarian Dutch twins, and they have photographs of each of them. And whichever one looks younger ends up living longer on average, right? So perceived age is a big deal when it comes to mortality. As a predictor, it's just as good a predictor as any other sort of biomarker you could use. Yes, sir.
Do you have a sense of whether the kind of weak effects, granted they're weak, but could even those weak effects be explained by expectations? So it's if you expect the person you're interacting with to be very trustworthy or very not trustworthy, that itself could influence how trustworthy or not trustworthy the other person behaves.
Yeah,
so there's kind of this feedback.
Yeah, there are possible self-fulfilling prophecy effects going on, but it can also go in the opposite direction too, right? So Leslie Zabrowitz has this cool work on baby facedness. So people whose faces look more like babies, people think that they overgeneralize to them being like babies. So they're helpless and not as smart and stuff, right? But as a result, they compensate. So the people who have baby-faced faces end up being more competent and more self-reliant to overcome the impressions that people have of them. So it can be a little bit messy in that regard. I think in static photographs of adult faces, single photographs, I think it's very unlikely you could read out people's personality from them. The exception being the things that you want people to read out of them. So if you go on a dating site, the picture you choose is going to be very different than if you go on LinkedIn, which again is going to be very different than the picture you choose when you want to show you had a crazy night out with friends on another social media app. So there's an aspect of self-presentation that gets lost in this conversation as well, that matters too, I think. Well, back to the talk. So to get at this question, I'm gonna use what is akin to the children's game of telephone. This is where you start off with some message, you pass it down, whisper it into someone else's ear, and so on down the line, until the last person recounts the message, And everyone erupts in laughter because it's completely different from what the message started out being. The cool thing about this game is that if everybody playing the game shares the same assumption, the message ends up turning into that assumption, because the errors that propagate from person to person aren't entirely random. They go in the direction of the assumption. So a shared assumption leads to a shared reality, leads to a shared outcome at the end of it all. As a result, this kind of paradigm is really well suited to linguistic stimuli, or asking questions about concepts or stereotypes or gossip. So we know, for example, that stereotypic information is passed with greater fidelity. Gossip, right? Third-party social information is passed with greater fidelity than non-social information. But I don't do this stuff with language. I'm not a language person, I'm a vision person. So I do this with visual stimuli. And in particular, I've done it with faces. So this is an example of just how we're going to use the logic of this for our question. This is just an aside, a parenthetical. But here we looked at sort of what our assumptions for race were, at least among white participants, where we had a face transfer from mind to mind over the course of 10 participants in a given chain. And we found that within 10 faces, white participants turn even a very black face, a noticeably black face, into a white face. So to give you an idea, that red line, the face goes from that face at the top right to that face at the bottom left in terms of within just 10 participants on average. So it's a big categorical shift. And it does so by like accumulating little errors where the default assumption is white, you make the face a little bit whiter, the next person makes the face a little bit whiter. So we'll use that to show this whitewood bias in race memory. But here we're going to use this not for linguistic stimuli or for faces. We're going to use it to transmit relationships, relationships between how, say, trustworthy a face looks and how trustworthy that person is believed to behave. So the logic is like this. Imagine a first participant learns some relationship just between two variables, X and Y. It's a very simple linear relationship. Then they have to reproduce that relationship at test time. They add some noise to it. But then this information becomes what the next participant has to learn from. And then they reproduce that relationship in a slightly different way, which gets fed on to the next person and so on. So the broad question here is, how is it that stereotypes manage to propagate despite weak evidence? But the more narrow question is just, we're formalizing this in terms of people's priors. What are people's priors or expectations relating how trustworthy someone looks to how trustworthy they behave out in the world? So on our y-axis, we're going to have just how, sort of like a measure of behavioral trustworthiness, like how much does this person share in the context of an economic game? And on the x-axis, we're going to manipulate perceived trustworthiness using one of our older models and see what happens as we move along. And we can start people off with 4 different types of functions: a simple positive linear function, which is the most basic kind of stereotype. More trustworthy face means more sharing. A negative linear function, which is the exact opposite. So the more trustworthy people are snakes. A non-linear function where the people in the middle are the ones to be wary of, and complete random noise, where there is no relationship to begin with. There's 2 phases to the experiment. In the learning phase, they start off by seeing a face, and they just have to guess, basically, at the start, how much do you think this person shared with their partner? And then you guess, that's in blue, but then you get told, actually, the correct answer is this, in yellow, and you have to adjust down to that answer in order to move forward. So this gives you a chance to learn the thing. And you're also incentivized to learn quickly, because the next trial comes up, and if you get within the ballpark of the right answer, you get a little bonus to incentivize you. And you just do this 30 times. Then in the test phase, it's exactly the same, except now you don't get any feedback. And the answers you give here become the feedback for the next person who comes along. So this becomes the stuff in yellow for the next person that this will get fed to. And you do this 30 times as well. With 15 faces you saw before and 15 brand new faces, you have to generalize the pattern too. We do this for 10 chains of 10 generations of 10 steps each with these 4 different things. And I'll just note that this was a relatively hard experiment to set up because it's all done online with like live data quality checks and other things. It was a pain to get up and running. Bill Thompson was a huge help with this. But we can always geek out about the tech stack later if you'd like. The results are as follows. In blue, so on the y-axis, I'm going to post like the correlation, right? Like what's the linear correlation of these relationships? And on the x-axis is going to be steps. So we're stepping forward through time from left to right. in terms of positive linear relationship, people had zero problem learning this. People just get it, like the more trustworthy, it's the stereotype they have already. With the negative linear condition, they end up weakening that stereotype over time. My belief, as you'll see from the other stuff to come, is that if I extended this out another 10 steps, it would have shot up to the blue line, but you'll see why. In the nonlinear condition, people eventually gravitate towards more and more positive linear trends until it's basically overlapping with the blue line. And even with random noise, when there's nothing to begin with, people enforce a much simpler, more stereotypic relationship onto the data. So within just a few generations, the looks of the faces end up mattering more than whatever the initial seeding conditions were. And this prior is strong enough to eliminate or even reverse that initial relationship. Yes, Neil. Yes, the zero is what we see. Yes. Yes, that's right. Zero is like the initial, is not a subject's data. Zero is the seed. Yeah. 1 through 10 are also. Yeah. Yeah, that's right.
The participants informed that they had to learn a relationship.
Yes. Well, they were told that your job is to get an understanding of who is going to share in this game. And we're going to incentivize you to learn as best as you can. And then at test time, we're just going to see how well you did.
Is that like a game?
Yeah. Well, better in air quotes, right? Yeah.
Even negative linear, it seems like they are trying to learn a certain mapping, right?
Yeah. They do try to learn a certain mapping, but if I showed you the individual plots too for the negative linear, like by the end of it, it becomes like random noise, right? By the 10th chain, basically. And sometimes they end up, on occasion, they'll end up enforcing a positive relationship, even with the starting negative one. It's very hard for people to overcome that. It's interesting too, because the nonlinear relationship is also very easy to put into words, but people can't do that task for some reason. Well, when I say they can't do that task, they enforce a simpler relationship on the data at come test time. Yeah. Sorry, Jeremy.
Do you think the blue line, when you start off with a correlation of 1,
Mm-hmm.
and it shrinks a little bit? Do you think it's like, do you think that's meaningful, or is it like, your IT only can't get a correlation higher than 1, so anything you average it with will necessarily be lower?
I think that it's the nature of the testing procedure, right? Like in social sciences, we're limited by relatively noisy procedures. So these faces are normed on other people's data, right? In order to generate them, to look more perceived trustworthy. Your internal model of what trustworthiness looks like in faces is probably a little bit different from mine, is a little bit different from someone else's. So I think that's where the noise comes from. Yeah, sorry, Robert had a question.
Yeah, I was going to ask about there's some of the design here that's like it's a fairly open-ended thing where you don't see the same faces more than presumably. You just see like a big sample of different faces.
Mhm.
And I wonder whether like a lot of our kind of social processes are like repeated partners. So it'd be like, if you see the same face maybe like 5 times, you would like learn a much stronger, you would learn to like recognize them and bind it to the thing they actually did.
Mhm.
But like you've almost built into the sampling procedure that the only thing you can use to like predict it is this like held out, like kind of like generalization function that like yes.
Well, it's not the only thing, right? They do see half the faces twice. So at test time, they do see 15 out of the 30 faces they originally saw.
I kind of meant like during training. Like,
Yes, that's true.
And this is also like an older thing from Tom's like,
Mhm.
it kind of depends on to some extent.
Yes, I agree with that. I mean, I think that these kinds of procedures require noisy memory representations so that we can better measure or more quickly measure the prior. Yeah, for sure. that is an artifice on our part. Yes, absolutely.
Yeah, this is really interesting, and I'm really curious if you've looked at the individual participants' trajectories across these different models, and if there are some people who differ, and if so, if there's maybe any like individual differences in terms of like people's traits that might be associated with them imposing simpler models, like tending to impose simpler models, or like paying more attention to
I think that's a beautiful question. We don't have the power in this study to do that. What I can show you very briefly, if I can figure out how to show individual slides really quickly. Oh, why did I do this? What you would want is you'd want a paradigm where you've got like within subject chains. So you could see that person's data evolve over time, right? When here, they're just contributing in a way, one data point, right? They're contributing one graph's worth of data, but you'd want one where the participant can like do a lot more. But let me show you something cool. This is all the data for the random condition. So each row is a chain, each cell is a participant's data, and the first column is like the seeds, right? What the first participant saw and learned from. Then they reproduce the next thing, which was fed to the next person, et cetera, right? So this, you could see like all of them, all these seeds are a little bit different, but they're random noise, and then they gradually just go boom, 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 simple linear relationship. On occasion, you'll see some negative linear ones like down here, and it'll even go like perfectly positive linear, and then some people like sort of flip the relationship. So I think that there's really cool individual differences work to be done, but the paradigms that I've been working with so far don't allow for that. But it's an open question to me. Yes. Sure.
There's like usually you try to sort of things.
Wait till you see part 3. Awesome. Anything else before we move on? Let me see if I can find my position. Oh, yeah, Robert again. Sorry.
I feel like I phrased my question extremely bad. I think that I just thought of a better way to ask it, which is in the non-linear case, which I think is the case that I'm particularly interested in, where like it is a particularly untrustworthy person, like that, right? I feel like there is kind of like, if there's like a salient, like amount of untrustworthiness attached to like a particular person, I feel like the memory effect there is like there's maybe a magnet around that person, and like if I'm actually gambling at a casino or something, and like I see somebody that I think is cheating, I like remember them more, right? And like I wonder whether like how that kind of like saliency in memory of like extreme, like values might manifest. And like, is that a thing you can test?
In a way, I mean, but only like really with the first maybe couple of people within the nonlinear chains. So it's a case that like they would have seen somebody with that extreme level of untrustworthiness, but then by the 10th person that gets washed away, right? Like sand castles on the shore. So yeah, we would have to look at that. But that's a very cool separate kind of question, I think. Yeah, I'm gonna skip past experiment 2. And just say very quickly that what we found is we hope a positive linear prior relating how trustworthy people think faces look to how trustworthy people think those people will behave. This can emerge even from random noise. And this may be one way in which stereotypes can find themselves propagating through society, because even if they aren't true, they're still sticky. It's very hard to obliterate them. But this project was like, I had to show this because it's part of the narrative. This is this is a great example of my frustration with face perception research, because the faces that I've shown you in this talk up to now look like this, right? And these faces are super duper evocative. They've been useful to hundreds of labs around the world over the years. They give you vivid impressions. but they don't look very real. They're bald heads on black backgrounds. They look mannequin-esque. It's very hard to convince people that, hey, these are people's faces for my studies, where maybe you need like a cover story, right? So I had to tell people in that last experiment, in order to protect people's privacy, I like put them through a 3D facial program, and like, these are real people, don't even worry about it. There's some hand waving. So it's a problem. It's a problem if you need real, believable stimuli sometimes. On the other hand, in cognitive and social psychology, you can use real people's faces. But these have other issues. One of them, for example, is privacy and dignity. So these are real faces from a real database, and I can only show you these 4 faces in this talk because they're real people and they want to go about their lives and not have to deal with like thousands and thousands of people seeing them all the time. You also can't manipulate them very easily, whereas it's super easy with a computational model to transform different features of faces that you might want in your reductionistic experimental designs like me. With these, it's much more difficult. You got to use Photoshop or very advanced techniques. So if you'll recall these faces from the beginning of the talk, these ones, this is where, if it were a less savvy audience, I could say, and these aren't real. Who noticed that they aren't real? But I've already shown you too much over the course of this whole thing. But this is my way of dealing with this frustration. So what we did was we took GAN, style GAN 2, which out of the box lets you do all kinds of cool things with it, right? Like these, you can make these fancy transformation, Michael Jackson-esque black and white videos. Why is it? It's like going really slow for some reason. Like they're supposed to go at like 60 frames per second and look nice. Yeah, like this kind of transformation. But then it just quits out because my computer is not very strong. And this must be like a 4K monstrous monitor or something. But the thing is that it's kind of like gambling at a casino. You pull the lever and out comes a face, but that face could be anything. That face could be what looks like a 45-year-old black lady with glasses who's smiling. It could be an 8-year-old Asian child with a hat. It could be anything. So it's a bit of a black box. And we wanted to put reins on these models so that we could answer our questions within psychology. So our goals with this project were to be able to generate realistic and diverse faces that you can vary along any attribute you care about, to transform any face along these kinds of attributes, and to be able to, as a corollary, predict judgments of any given image of a face. And this is where I have to point out that this is about judgments of faces. There's literally no ground truth here. This is about what people think of faces. It's not about like trying to model what people are actually like out in the world based on a single photograph of their face, because I don't think that's possible in principle or in practice. And our procedures couldn't do that. Like it's literally fake faces. I can't begin to tell you how often I'm at like a party or something and people hear AI and faces and attractiveness, and they're like, oh, you're trying to usher in some dystopian social credit hellscape. You're trying to make it so that like when I go to get a bank loan, people deny me because of how I look. And it's literally the exact opposite. I want to know why it is that you might be denied a bank loan on the basis of how you look. I want to be able to like stop that. And the way that we do that is we do it with science, knowledge. Yes, Jeremy.
Like, when I was in college or grad school or something, I read some papers with these like they're called Wilson faces. It's like you take they look really bad, not realistic at all, but they were like kind of like almost high spatial frequency, like high pass sort of face-like things where like the different dimension in the space were like, you know, the sizes and distances apart of different facial features. And so like if you move along any one dimension, a specific feature changed. But these like kind of fancier spaces, do you have a sense of what the dimensions are, or is it just like you're somewhat arbitrary and it's like you can kind of map on dimensions of perception to these spaces?
Yeah, it's just, it feels totally arbitrary and entangled, right? Like, yeah, but you'll see, I'll show you more shortly. So to try and put reins on this, we asked people about 34, a grab bag of different features you could read out of or into faces, or problematically. So some of those that we talked about, like age or gender, but also more high level things about what people thought about their personalities. And also some things that were just like kind of off the wall, like smug or dorky or privileged, like interesting, fun things that people hadn't really tested in literature before. And the way that we did this was we made a bunch of faces. We made over 1,000 faces. This is to give you a sense of the diversity and range of those stimuli. And then for each face, for any given person, we just asked, how X does this face look? On a scale of 0 to 100, they don't see the numbers, except for age. With age, you have to see the numbers. But then you can just click on the slider to record your judgment, if you'd like to show. And then those judgments become the values that you try to predict on the basis of people's on the basis of people's of the faces like matrix. So every face can be thought of as like a list of 512 numbers, right? Which is what this is. I'm just like decomposing it into some big matrix. So we have this like 1004 by 512 matrix. And then you just do linear regression on them through this space where you're trying to predict the mean ratings of these faces. So we did this with like over 10,000 participant sessions from over 4,000 individual people. We got over 1 million ratings, over 1,000 images rated. We just got it published about 18 months ago now, funded by Princeton. And I can show you all kinds of graphs about how well it works, but it's better to just show you the stimuli. This is the dimension of perceived age as you go from left to right. The older faces look older. They also grow glasses sometimes, right? They perceive trustworthy faces. A lot of things change. They become more smiley, more feminine. They also look at the camera, which is not something I was expecting. So eye gaze direction matters for this particular judgment. And the image as a whole changes. These are holistic judgments to sort of go back to Jeremy's point, like even the backgrounds change colors a little bit, the eyebrows change, everything about the image is changing at the same time. For perceived smart, they don't seem to think that sleepy kids are very smart, but they think that older adults with like slightly asymmetric smiles are. And again, they grow glasses sometimes. Glasses make people smart a lot of the time. I'm gonna skip memorable. Oh, this is one of my favorite ones, outgoing. If the face happens to have sunglasses, this is the bottom one, you'll notice that the sunglasses actually become brighter colored, rounder shaped. So it's really changing a lot of stuff at the level of the image, like holistically. This is just a little video demo of a face going from very, very quote unquote untrustworthy to more and more so. Yeah, all the obvious things happen, but also the background becomes like less muted and more bright as you go from less to more trustworthy.
Logic of using of keeping the context or the background.
The logic was that that's part of just the face space. It's just literally like the raw images put out by StyleGAN and just using the numbers that come from StyleGAN raw so that we can model it as best as we could. Yeah, because I know in psychology generally, we want to have the backgrounds like removed and everything. But that's part of these portrait style photographs is the background. And if you've ever had a portrait taken by like a friend who's really good at portraits, they like spend a lot of time thinking about the light and the background you're on and everything. But I think, yes, especially that, right? Like, imagine your background is like a blood dripping wall, right? With all kinds of death metal things going on versus like a lovely forest environment.
I see.
Yeah.
Yes, like maybe two thoughts on that. Like I kind of had a similar question, which is, if you're interested in like overall versus, but like that's suddenly not a face perception anymore, maybe. Because like if you just blurred out the face, you could maybe still make really good judgments about it. So like, and that from fertility work and your vision, like often like that's like basically like completely remove or mask out like all of the face parts and like makes the judgment based on the background. And like at what point are you still studying faces versus kind of like the vision of scenes or kind of like all of it?
So I mean, keep in mind that like the backgrounds are maybe like 4 percent of the total area of these whole images, right? I can show you as well, like if you give it a face or you find a face that doesn't have a background, the face still transforms along trustworthiness, even as the background stays completely matte and white or gray. So I do think this is about faces. I don't think that these judgments would work if you masked out the entire face and only left the 4% of pixels or so left of background. I think that it is the case that a lot of stuff, you know, in vision and in a lot of experiments, we don't give enough thought to how this information is redundantly encoded, let's say, right? So I think that you could blur the faces and recoup a lot of the information, or at least the classification accuracy or prediction accuracy. I think that you could look at the color distribution, right? So we know, for example, from like IAPS images, if you're familiar with IAPS, the International Effective Picture System, Brian had some cool work showing that you can scramble those images up completely, right? Put them in a blender and just get like the color and spatial frequency distribution. And people can still tell, like, is this supposed to be a positive mood image versus a negative mood image? But there's content to them too. The content does matter, right? The content of an image of someone triumphantly on a podium holding a medal, that says something that a blend of colors does not. And the same goes, I think, for these faces. Okay, great. So just quick conclusion for this. I think we've met our goals. We can now generate these kinds of faces. We just need lots of data to get any given perceived attribute that you might want. And we find that sometimes surprising features drive these impressions. Like, for example, the eye gaze stuff from trustworthiness. And this is like an especially direct way of visualizing the biases that people have in their heads. People talk a lot about biased AI models, which is true. Every AI model is biased, including this one. But this one is special because this is not just a biased AI model. It is an AI model of bias. It turns bias into the object of study that you can use to better understand or predict what's going on in society, or try to manipulate it and intervene and see if you can actually improve how people think about these things. I'll actually show you very quickly one last thing to show like the direction we're going in with this. Back to Eshen's point, right? If you're familiar with reverse correlation, if you're not, that's okay. We're going to walk through it very briefly. But this is like a way of getting at what are the pictures in our heads, right? To paraphrase Walter Lippmann, that a stereotype is a picture in our heads. This is a behavioral way of pulling that information out. So the way that it usually works is you start with some base face, you add some carefully constructed noise to it, and then you add like the opposite of that noise to it as well. And then you put those two images side by side, and you just ask to make a judgment. Which of these two faces looks more X, whatever category you want, more female or trustworthy or whatever have you. And then you just average up all the ones that people chose. Please. There we go. You average up all the ones that people chose, and out magically comes a classification image, the image of what the group as a whole thinks that category looks like. And our lab has used that for all kinds of interesting judgments, like trustworthy faces look like that one on the left, untrustworthy faces look like that one to the right, and so on. And you can use this as a way of like visualizing and understanding prejudice as well. So if you use like, if you look at, I think this was either German or Dutch participants who were judging Moroccan faces. People who were more prejudiced against Moroccans had like more scary looking Moroccan classification images when they just had to make the judgment, make a Moroccan face basically. Or choose the face that was, they don't know that they need to make a Moroccan face. They just have to say which of these two faces looks more Moroccan. And that ends up making a face of a, anyway, the more prejudicial people make more scary faces. This recently took the world by storm, or at least on social media, on Twitter, where they looked at people's in-group and out-group representations along political orientation. So the top row on the left is what conservatives think conservatives look like, but the one on the bottom right is what liberals think conservatives look like, right? Like literally one of us, right? And one of so this kind of result is very evocative, but the images tend to be very, very low quality. It looks like you're looking through gauze or fog or something, and it's really hard to do individual difference work because of that. But now it should become easier because we have new techniques in part pioneered by Dan Albone in our lab, where the faces can look crystal clear. So instead of adding noise at the level of the pixels, we can add noise at the level of the latent representation. So every face comes out looking like a real face, right? So it's a very natural judgment. And now we can just show one face at a time and ask you, does it look A versus not A versus you're not sure? And with like a very simple algorithm, we can pull out what people think that looks like, that category looks like. So in this pilot study, well, we're writing it up now. But we were looking at people's representation of leadership. What does a good leader look like to people of different political orientations? How does that differ with your political beliefs? How does it differ with your attitudes towards women? So for example, we ran a bunch of surveys on people. We saw that conservatives get higher scores on various types of sexism and economic and social conservatism. And this bears out in the faces that they reproduce. So on the top row, I'm showing the dimension of leadership pulled out by conservatives, going from less leaderly to more leaderly. In the middle row is moderates, and in the bottom row is liberals. Yeah, so the conservatives have this really big gender difference. So everyone agrees that the leaderly faces should be more smiley and smart looking and electable looking and trustworthy looking. Everybody has those stereotypes, but the conservatives have this really strong gender bias that isn't there with anyone else. And when you ask other conservatives and other liberals and other moderates to rate the individual faces, this is the average, this is a group average. But when you look at the individual faces and you ask, oh, sorry.
Face in the other groups at all. Like, isn't that?
No, because that's the bad leader. That's the bad leader.
The leader in the other groups, isn't it? Is still a man.
Yeah.
Yeah, the good leader is still a man.
Well, this is on
Bad leader, like just women, it seems like women just unrepresented leaders.
if you look at the individual data, the individual subjects, there is a lot more female represented. So for example, like if I've got this, for example, these are just a sample of different individual models made by individual participants for the liberals. You see that like there's quite a few female faces that come out with the individuals.
The average is still men.
The average could be like an artifact of just like, you have to center the data somewhere in the space. So depending on where in the space you choose to center it, the individual face can end up looking more or less masculine. You could put that wherever you want in the space. The point is we're looking at the difference between the good and the bad. The difference is what matters for this particular question. But yes, it is the case that the liberals do come out with female representation sometimes. So that's a great point. Whereas if you just look at conservatives, it's wall of men. Does that make sense? Yeah, on the bad leader side. That's the point. Yeah. And the thing is too that like people prefer the faces that their own group makes. So if you ask them to like rate how willing you would be to vote for this face made by a particular other participant. If you're conservative, you want to vote more for the conservative participants' faces, good leaders. If you're liberal, you want to vote more for the liberal, good leaders. If you're moderate, you don't really care so much. But everybody agrees that the good leaders are better leaders than the bad leaders, or more votable. But your group representation matters. So this just shows that this is like a particularly direct way to reveal a new kind of gender bias out in the world. And that it's unfortunately exactly what you might think of the participants involved. So yeah, there's all kinds of things we can do with this. But it's also the case that you don't have to do it with faces. So these exact techniques can be used for any kind of class of stimulus. You could look at what makes a pose look more outgoing. You could look at what makes fashion look more, I don't know, whatever trait you might judge fashion along. Voices, shoes, what makes a shoe look more sexy, what makes a car look more fast, what makes a bike look more rideable or what have you. So for example, you can like move along bike space in various ways and see things. And it is just my hope that these kinds of techniques can help illuminate the visual roots of social and other forms of cognition. Last plug, I'm going to be starting a lab next year. If you know any good grad students and or potentially postdocs, let me know. And I just wanted to thank all of my gazillion wonderful collaborators for all the projects you saw, because they are the best. So yes, thank you so much for listening.
Um, so I'm curious about the how do you train the network? As you mentioned, some data set may have some pairs, and and these pairs is could not be removed. So, I mean, how do you choose your data set to train model? And if this data has, how do you judge whether the data has some pairs or less pairs, and which will, whether it will influence your message of your pairs judgments?
What are you saying about are you saying bears or bells or?
One thing is the data set. So how do you choose the data set for, I mean, for training your network?
Mhm.
So the data set, some data set have some pairs, and how do you judge that?
Mhm.
Another thing is the data set has some pairs, and you train this neural network, and how do you counterbalance these two things?
So I think that I don't think that you're gonna get an unbiased data set in the world. Like, what would that even look like? Is it a face data set where like every demographic of human being on Earth is like represented equally? Even if you agreed that that's what like a demographically unbiased data set looked like, what about like the nature of the pictures themselves, right? These are all what does an unbiased portrait style photograph data set look like? Is it one where you want people like really angry, really disgusted, really like, I think you got to start somewhere. This seemed like a reasonable place to start, given that it was a data set that was released by NVIDIA a few years back, trained on 70,000 face photographs scraped from Flickr. Now, these are portrait style photographs. They represent the things and the subjects that those people want to study. So this is not perfect by any means. This is not the final coda on face perception or face perception models, but it is a start. And the other thing too is that it depends on your use case. So if you want to use faces to decide like who should get a bank loan, well, A, don't do that. But B, if you were going to try to do that, which you shouldn't, it should at least be like something that you were very, very careful about collecting and understanding and characterizing, right? Your use case matters. Here, the goal is to create a psychological map of bias. So I'm not as concerned about any potential deleterious use cases there, because we're not using it for these like scary things. And even if people were to try to use these for scary things, because we're using a well understood, well published data set, you could actually go right now on like say Google Chrome and download an extension, a little Chrome extension that instantly tells you if the face was made with this thing, right? So you can't even use this stuff to go and like catfish people or make fake LinkedIn profiles without being discovered very, very quickly, or at least trivially, right? Because you can literally just right click on the image and say, is this fake or not? And the thing will say, yeah, it's fake. So yeah, it's a way to start. Sorry, in the back. I too am curious. I don't know. I mean, Philippe Shins has some work on that with like these 3D models of faces with like face pull sort of things. The demos I've seen of that work. Are we still recording? I'm not particularly convinced by, but it's a start, right? It's a way to start. I do think that we need to move more towards video and dynamic stimuli for sure. This is just static photos. So it's very, very limited in that. So try. I think it varies. I think it varies a lot. Yeah. I mean, the models themselves are linear. These are just linear models. We could probably get way better performance if we use like fancy nonlinear models. But I could easily, I mean, for categorically, some things just appear, right? So for example, glasses sometimes just grow on the face, right? And that's like a very abrupt shift. right? One frame they're there and the next frame they are. Yeah, so, yeah. Just understanding what the breakdown is or the contribution of these various other features that we could pull out as people is itself an important project, I think, because this is extremely holistic, right? Because it's tailored for my use case as well. I care about the perception of the image as a whole. But particular people are going to care about like, what is the role of like the corners of the mouth in trustworthiness perception, or of skin color, or of whatever have you. But that's, yeah, something to explore down the road. Yes, yeah.
Really interested in learning. So I was so great to this topic of expectancy models. We assimilated the fast and expect. However, it's like things that are very slightly different from what is like I think this type of be assimilated to it to get that non-linear model. Like if it's slightly deviating from what we thought, if that's the instead of then things actually agree or not possible, whether it's really different. So you see like very uncertain cases where all that it is just really it's hard to move on. It's really difficult. So I'm curious if you see that in the outcomes there, things that are slightly deviating from this.
We could probably look at that. Yeah, because I mean, like, in a way, we just got all these like data points of just like moving from this point to this point in space, right? Like tons and tons of those data points. So we could look at that. I think there might just be enough data to do that. Yeah. Next day.
What sort of contextual needs do you expect to find in these sort of judgments? And the question kind of comes from in the facial expressions of emotion literature. People often think that they're studying some like core, like true value of an expression. But what we find is that when you introduce contextual information, that shifts wildly. And so if you don't model the contextual dependence of the judgments, really what you're doing is just asking observers to like marginalize over some unknown set of context to give you a point estimate, and you're treating that point estimate as like an expectant of some true value, but it's not really. You really have to do the work of adding contextual manipulations to understand like what you're studying and whether you're there is like a true value that you're getting at, or whether it's something else. And so like in the data that you're collecting, is there value in trying to add contextual information to see how your judgments change? Or do you think this is really like some true value that you're approximating with lots of subjects?
No, I completely agree. I mean, this goes back to like the naturalistic versus reductionistic approaches. Are very, in a way, it's closer to the reductionist side, the design we had, but context matters. So for example, if you just show people, we're finding out now, and this is work with Ray, if you just show people neutral faces, like totally neutral face photographs, that aren't showing, supposed to be not showing any emotion on them. But you tell them this person is high social status versus low social status. People read very different emotions into the face. So context 100% matters. The little vignettes you give to faces matters. Telling people this is an axe murderer versus this is a baker totally matters how you're going to view these images. But that's step 2 through 2000, I think. This is step 0.
So I think lots of cool discussion, and we could keep doing this all day, but let's